morning, mathematicians. This is our Section A checkpoint for Unit 6, and we're starting off in number 1 with some multi-step problems involving measuring conversions. So the first thing that I want us to think about is about the reference units that we're going to be utilizing as we complete this table. I see that this table has kilometers, meters, and centimeters. So what are the relationships between those? Well, I know that there are 1,000 meters in 1 kilometer, and I also know that there are 100 centimeters in 1 meter. So I know that those are the relationships that I'm going to be doing as I'm converting between kilometers, meters, and centimeters. So initially, notice what is happening in my chart. Initially, I'm starting with the idea of kilometers and I'm converting to a smaller unit. It's going to take more meters to communicate the same distance as it is measured in kilometers. In fact, it's going to take 1,000 times more. So to go from kilometers to meters, I know I'm going to have to multiply by 1,000. If I'm multiplying by 1,000, really that is like that decimal is moving 3 times to the right. Here's 1 movement. Now 2 and 3 movements. So I know I need to plug in 2 zeros and I have an answer of 1,700. Now I'm going to go ahead and clean this up a little bit because I want to get rid of where that decimal was when I first started that conversion and that process of moving the decimal, because I want it to be very clear that if I have 1 7/10 kilometers, that same distance is 1,700 meters, right? Now, to go from meters to centimeters, I'm going to yet a smaller measure. So once again, I'm going to have more centimeters to express that same measure. In fact, I'm going to have 100 times more because there are 100 centimeters in 1 meter. So once again, I'm going to take my number and I'm going to move my decimal to the right, this time 2 times, and that does mean I have to use 2 placeholder zeros, right? Now let's go ahead and once again, let's clean up this number. I'm even going to rewrite my zeros, those 2 zeros that I added to the end, and let's do 1, 2, 3, comma, and I now can see very clearly that I'm going to have 170,000 centimeters, and I'm going to have 1,700 meters and 1 7/10 kilometers, right? Okay, for now, I'm going to go ahead and leave the arrow in blue that shows going to a smaller measure. There is only one more time when I'm going to be converting from, in this case, a meter to a centimeter, which once again means we're going to have to multiply by 100. Because if I have 23 meters and I want to express that same distance in centimeters, I have to have 100 times more. So here is 23, and if I move my decimal 2 times to the right, that's really adding 2 zeros. That's making it 100 times larger. So now I've finished all my conversions where I'm starting with a larger unit and I'm going to a smaller unit. So now all the conversions that remain are the opposite. For example, in my second row, I'm starting with 15,900 centimeters, and at first I'm moving to meters, which means that I'm going to be dividing by 100. If I divide by 100, what I'm doing is I'm moving my decimal to the left 2 times. So my decimal started here at the end in this number, 15,900, and now I move my decimal 2 times to the left, 1, 2. That is where my decimal now is. So my answer here is that I have 159 meters. The zeros at the end are optional. I'm going to go ahead and take those off just so that it's very clear that my answer here is 159. Now to finish that row, I am once again going to a smaller unit because if I have 159 meters and I want to convert that to kilometers, I'm going to be dividing this time by 1,000. 1,000 has 3 zeros, so I'm going to be moving my decimal 3 times to the left because that will reflect how many kilometers are in this number of meters. In a whole number, the decimal starts at the end. So to move my decimal 3 times to the left, I'm going to move 1 time around the 9, 2 times around the 5, 1 more time around the 1, and now I have an answer of 159 thousandths. I can put a 0 in the ones place or not. That 0 is optional. I like to put it there because now look, it's very clear that that is a decimal number, 159 thousandths. There's one more conversion that we're going to be completing in this chart. We're going to take this from 23 meters to kilometers. So once again, we're going to be dividing by 1,000. So I'm going to start with my number 23, and I remember in a whole number the decimal starts at the end, and I'm going to move 3 times to the left. 1, 2, 3. Now where I have a movement but I don't have a digit to move around, I plug in a placeholder 0. Once again, that 0 is mandatory because it's pushing the 2 and the 3 to that right place value. This 0 that I'm putting in the front is an optional 0. I don't have to have one in the ones place, but I'm going to go ahead and add it. It was a good opportunity to talk about the difference between mandatory zeros and optional zeros. Now, before I say my number 1 is done and move on, I'm going to clean up my chart a little bit. Right now, my chart has all of those arrows, and whether we were multiplying or dividing, if you need to look at that and study it, pause it now. Because right now I've got a lot of scrap work on here. At this moment, I'm going to go ahead and take off that scrap work, and that way it's very clear what we were looking for. Went a little too far with that one. Let me write that back in. What we were looking for with our answers was just these numbers that expressed the actual value of kilometers, meters, or centimeters. And now if you take a look at my chart, you'll see that my chart really does just have those particular units that we needed in order to express our answers. So now we are ready to go on to number 2. And in number 2, we're thinking about powers of 10. In fact, we're looking at and thinking about and analyzing some different patterns that exist as we multiply and divide by a power of 10. So as I take a look at the number that is provided, I see 100 million, right? 100 million. Now right away that tells me that either this B or this E can be correct, but not both of those. What I said in word form was 100 million. So that should help us to understand that that is the correct way that we would say this number, 100 million. So for that reason, B is not an answer that we will choose. And in fact, I also know that D cannot be an answer that we choose. 100,000 is not the same as 100 million. So now let's take a look at A and C. Those are the ones that we still need to look at. First of all, in A, I'm going to zero in on this number right here. That exponent is an exponent of 8. And we have found the pattern to be true that if I have a power of 10 in exponential form, 10 to the power of 8, that should be a 1 with this number of zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, comma, 1, 2, 3, comma. Take a look, that checks out. This is exactly the same as this. So I do know that A is an answer choice that I should choose. 10 to the power of 8 in its value form is a 1 with 8 zeros. So that is true. Now let's take a look at C. What we also know to be true is that if I have 10 to the power of 8, or if I have 8 zeros, right, that should be the same thing as 10 multiplied together 8 times. This is 4 times, 5 times, 6 times, 7 times, and a squeeze, but there's 8 times because 10 to the power of 8 is the same as a 1 with 8 zeros and is the same in multiplication expression form as 8 tens being multiplied together. So that's what we need to look for here. Do we have 8 tens being multiplied together? Let's count them. We have 1, 2, 3, 4, 5, 6, 7. This represents 10 to the power of 7, which is not the same as 100 million, and it's not the same as 10 to the power of 8. So I know that C is not an answer that I should choose. The only answers that we should choose should be A and E. Now let's go ahead down and let's take a look at number 3. For number 3, we're returning back to the idea of measurement conversions, but here it's tucked within a word problem. This is a good opportunity to think about this in a word problem and break it down. So here we see that it is 325 meters around the track. Jada ran around the track 12 times. How many kilometers did Jada run? Of course, if this were the first time that I were solving this, I would want to read this repeat number of times to make sure that not only do I understand the numbers that are in my problem, which we should circle, but also I want to catch and pay attention to the fact that when I multiply those two numbers together, that's going to represent the number of meters that she ran. So 325 times 12 is going to represent the number of meters that she ran. The next thing that I have to do, because I read this very carefully, is I'm going to have to convert that to a certain number of kilometers. So I have to catch that detail. But my very first, as I think about my problem solving plan, the very first thing I'm going to do is I'm going to multiply 325 times 12. Now I could multiply 325 times 10, right? And then I could add 325 times 2. I see a couple of our students have done that, and that works because 12 is a 10 and a 2. So we can kind of create a number bond there to see that. That is one strategy that can work. Let's go ahead and try that. And then, of course, we could even try out standard multiplication. But here, this works well because we can take our 325 times 10, and we know that we will simply have our 325 with an extra 0, right? Now here we have 325 times 2, or 325 added together 2 times, which as I take a look at gives me 650. So here I would have 3,250 plus 650. I'm going to come to the side here and do my 3,250 plus 650. When I add this together, I'm getting 3,900. So here I'm going to go ahead and write that in, and I'm going to remember what I said from the beginning. This is the number of meters that Jada ran, which is an important step for me to get to at this moment, because now what I'm needing to do is I'm needing to take my 3,900 meters, and I'm needing to convert that to how many kilometers that is. We remember the reference relationship. We actually wrote this at the very top of our page, but we remember our reference here is that in 1 kilometer, we have 1,000 meters, right? So to go from meters over here to kilometers, we are going to have to divide by 1,000. It's going to take less kilometers to express the same distance. So I can take my idea of 3,900 and divide it by 1,000 by moving my decimal to the left 3 times. 1, 2, 3. My decimal will be here, and my answer will be 3 and 9/10. So my basic answer here is 3 and 9/10 kilometers. Now, before I go any further, in fact, because I do see several students who have done 325 times 12, I don't want to forget to help you so that you can check your work if you did it this way. And if you did not do it this way, that's okay. It's still good for our brain to see this in different ways. We're going to start with our 2 as our center point of the problem. 2 times 5 is 10. Here's my 0, carry my 1. 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6. Now I'm going to put down a 0, cross off what I've carried, and I'm moving on to my 1 as a pivot point. But the great news is anything times 1 equals itself, including 325. 325 times 1 equals 325. So now I can add this together, and you'll notice we're getting the same answer here as we got here. That still leads us to this moment, which we have over here in purple, where we have to make our conversion. Our question that we were answering was, how many kilometers did Jada run? So the last thing I'm going to do is I'm going to answer that in a quick sentence. Jada ran 3 and 9/10 kilometers. I'm going to circle that statement and make it very clear that out of all that scrap work, that was my final answer. Boys and girls, that finishes out this Section A checkpoint.